All right, let's look at this logic that's due April 21. We have forever on it, but don't delay. Let's get to it. So here's how these go in case you're confused, though I will be able to explain it to you in person. Problem one says how many rectangular type boxes can be drawn using these points. So what you need to do is get a list. For example, I would draw and say, hey, there I could draw one like that, and here there's two, and there's three. Personally, I would be saying, hey, how many of these guys can I create? But do know you could create one like this. So how many of those guys could you create? You could create it like that. That's a different one. You could create one like, I don't know, what about that size? Or even, let's use a different pen color. We could create like that. So you need to sort of go through and think it through before you start just trying to draw a bunch of things. Hey, I can create this many of this. Hey, I can create how many of these? And then add it up and tell me the total number. Second problem, you basically have 19 coins, adds up to $2.46. How many quarters, dimes, nickels, and pennies do you have? That shouldn't be too hard. You have at least one of each. You can't say I have zero of one of the coins. So there could be multiple answers here. You just have to play with it. The biggest mistake that happens is y'all figure out something, and then instead of using 19 coins, you only use 18 or 20. You use too many. On this one, fill in the blanks using each of the numbers 1 through 12. So you need to make sure 1 is used. 2 we already used, so you've gotten that checked off. 3, 4, you have to use every single digit. And the key is each column and row has to have a sum of 17. They have to add up to 17. So when I'm checking this, I first check that you used every single one of the numbers 1 through 12. Okay. And again, not 2 because I've already used it for you. It sort of helped you out here. I then simply check, does that add up to 17? Does that add up to 17? Does that add up to 17? Does that, and does that? That's how I do it. If you're using these, you can't use, once I put a 1 in here, I can't use the 1 again. Because if I do, I won't be using all the numbers 1 through 12. So that's how that one goes. On the next one, basically, you're going to take the letters. We've done this before, I believe. Take these letters. It's going to break down into 2 words. Okay. So we know the first word's a 4-letter word. So what I would do is I would sit here and try to find some words in here that maybe, boy, there's a lot of O's. Maybe, like GOOD. Maybe good could be a word. Maybe it's HOOD, hood. I don't know. I don't see anything there. Maybe it's chick. I don't know. CHIC. So you want to try and write down a bunch of words and then figure out, it helps you then, maybe once you get this word, you then can figure out what the other 6 right there might be. Now, again, you need to do word 1, word 2, word 3. You might skip around a little bit. If you get stuck on word 1, go to word 2. Because again, 30 minutes means 30 total here. And after, 10, 15, if you're stuck on one, go to the next. At least give it a shot there. Problem 5. What digits do the letters represent in the below addition problem? So we know this D, this D, this D, this D, this D, they all have to be the same digit. Okay, they all got to be like a 5 or a 6 or a 1 or a 2. The biggest key here is notice that O plus O plus O adds up to L. Now, L is a digit. That means O can't be a 4, can it? Because if you have 400 something plus 400 something plus 400 something, that's going to be 1200 something. This is a single digit. It's the same as the L right there. So you know something there. I sort of gave you a clue. It can't be a 4, couldn't be a 5. So that gives you a little bit of clue. Number 6. I just moved into a new neighborhood. They've given me the brass numbers 2, 3, 7, and 9. Now, I want to put them up. Since I'm the first house in the neighborhood, I get to choose what my address is going to be using these 4 brass numbers. The only catch is that my address can't be 4 digits long. It can be a single digit address, a 2-digit address, or 3 digits. There's no 4 digits in the neighborhood. So I could have an address of 2 Hickam Way. Maybe I make it 23 Hickam Way, or maybe it's 739 Hickam Way. So what you should do is you should go through and think, hey, how many single digit addresses could he have? How many 2-digit? And then using these for how many 3-digit could you have? And you can't, this is all I have. You can't go 777. Doesn't work. It's got to be 7, then maybe the 2, then the 3, or maybe the 9, the 3, then the 7. You can't use a digit twice because this is all you have. You have 4 little things and you got to hang them up. And you get to decide how many different addresses can be created that way. This one, much harder problem. It says, what fractional part of the large square shaded? Now, fractional part. In other words, I want the answer to be, hey, 1/5, or maybe it's going to be 13 out of 45 spots. I don't know. There's a couple ways to go about this. You'll notice right away that this right here, that takes up 25% of the square right there. And then you got a little bit more in through here. Or you could maybe break the thing into real small sections and be thinking, hey, how many do you have? Okay, that one's going to take a little bit of thinking, but there's multiple ways. Students go many different ways to get the answer here. But the final answer needs to be a fraction. This one's pretty straightforward. From 1 p.m. to 6 p.m., how often are the digits of digital clock in ascending order? Ascending means going up. So 1, 2, 3. At 123, they're going up. At 124, they're going up, and so forth. I need to know how many. 122, it's not going up. It has to go boom, boom, boom. Okay? Has to be in ascending order. So how many different times are there? That shouldn't take you long if you list it. Number 9. Now, this guy's a doozy. This guy is really difficult to sort of follow. But we have 10 cartons here. And they go in the order 8, 6, 2, 5, 10, 1, 3, 7, 9, 4. So I want to pick up, and in 5 moves, I can pick up a bunch of cartons. Now, the mechanical arm can only pick up 3 at a time. It doesn't have to pick up 3, but it usually picks up 3. And in the end, I want to pick up, and when I pick them up, let's pretend that I picked up first these guys, and I dropped them here. That means it drops them. Boom, 1 falls here, 3 falls here, and 7 falls here. Now notice that means our order now of the barrels in there are 8, 6, 2, 5, 10, 9, 4, 1, 3, 7. So I then maybe pick up 2, 5, 10, move them here. Then it's 2, 5, 10. And now the barrels are in order 8, 6, 9, 4, 1, 3, 7, 2, 5, 10. Well, I'm not really getting anywhere. I mean, I could, if I want, I could now pick up 3 and 7, just those 2, and have to drop them at the end. So 3 and 7 are back here now. And at least now I have 1 and 2 in order. But I got to now maybe move the 5 and 10 back, right? To now have it 1, 2, 3. I got to get this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in 5 moves. Whoa. This is a challenge. Many of you will not get this. This, again, is difficult. But the key is once you pick them up, you're dropping them at the backside and everything sort of rolls forward. That's why I drew this little pretty picture at a slant. Okay. This is one I had back 30 years ago in college. Professor gave it to me. I thought it was a great problem. And the final problem here, what is the least possible value for 9? Now, again, these letters each represent a digit. That F and that F, they represent the same digit. And we're adding them together. It'd be awesome if it's like a 1 and a 1, making that a 2, but that might not be possible. I don't know. Okay. Now, each one represents a different digit. So if F is a 1, you can't let I be 1, nor U, nor R, nor V, nor E, nor N. Whew, a lot of digits, a lot of different letters in here, meaning a lot of different digits. So you got to work with this, and it has to be a true problem that whatever 4-digit number you pick here added to this 4-digit gives you an answer of a 4-digit number. But I need you to see if you can make the 9 the least value. So figure out what 9's value would be and write your answer. Good luck.